Hello everyone, in this video I will be talking about Node.js and the heart of Node.js, that is event loop. We will be covering event loop in detail with some code examples, but before diving into it, let's quickly understand what Node.js is along with code examples explaining its execution order.
To understand it simply, Node.js is a JavaScript runtime environment, environment where JavaScript is run because JavaScript can only be run in browser. But after Node.js came into the market, the situation changed and now we can run the JavaScript outside of the browsers as well. If we talk about Ryan, the founder and maker of Node.js, he made it in 2009. At that time, the most web servers handled requests using a blocking model. That meant when a server was processing one request, it cannot handle other requests. And Ryan wanted a more efficient approach, so he built Node.js around an event-driven non-blocking architecture. This design allowed Node.js to handle many requests simultaneously and making it very powerful, even though it is single threaded, but it handles works magically. And the technology behind Node.js. The main components of Node.js is V8 JavaScript engine and libuv with additions of C++ bindings. Node.js is built on top of V8 engine, which powers Google Chrome. V8 compiles JavaScript directly into machine code, making it extremely fast. Together, V8 and libuv allow Node.js to execute JavaScript efficiently while handling asynchronous tasks in background. The core components of Node.js, we can say that it is V8 engine, libuv, and event loops. And event loop is handled by libuv.
Here I will be explaining you the working behind Node.js. Suppose you have made a file called index.js in your code editor and you run this command node index.js in your terminal. What it does behind the scenes is what we are going to learn with this diagram here. A process is created after you run this command and a main thread, which is also known as single thread, and this main thread is the reason why Node.js is known as single threaded. But the way it behaves so magically is the reason why Node.js is so famous and popular. So the first thing happened here is a project is initialized. Your all top level code is run here. All the import statement happened here. And all event callbacks are registered here. After this, the event loop starts. And this is what we will be covering deeply into this video. Now let us understand event loops. Event loops internally is a while loop which has 6 phases and it runs in these execution orders. First of all, we have the timer phase where callbacks from shut timeout and set interval are executed after their expiry of callbacks. Next, we have pending callbacks phase where certain system level callbacks are executed. After that comes the idle and prepare phase, which is normally used internally by Node. Then we reach to the poll phase, which is one of the most important phases. Here, Node checks for completed I/O operations such as file reads, database responses, and if there are any I/O tasks which has finished, it executes it. Then we have check phase. Here, the callbacks of set immediate are executed. Then at the last, the close callbacks phase. Here, things like socket close events are handled. If all the callbacks in this phase has been executed, then at the end, while to loop asks if there is anything remained. And if yes, then it will start again. And if there isn't any callbacks remained of any phases, then this while to loop exits. And while to loop, the event loop finishes here. Again. Now let us understand the pool of threads. While the main thread is running the event loop, Node can also delegate certain work to pool of worker threads. This thread is managed by libuv library. By default, it has 4 threads, but we can increase or decrease it using this variable uv thread pool size is equals to 8. Here the thread pool will become 8 from 4. Okay, this handles heavy work such as file system, task encryption, and DNS lookups, and many other things. When the work is assigned to thread pool, Node does not wait for it to finish it. Instead, it continues to run the event loop. And when and the process and in the process it keeps asking whether the assigned work has been finished, and this process is called pooling, IR pooling. Now let us understand execution order of Node.js to the knowledge we have gained from. So here I have a console.log here and a set timeout function and another log here. What will be the execution order here? Let us understand. We know that the execution order is the first of all, Node checks whether we have any top level code, and console.log is a top level code. So what will happen here is, first of all this will run, then this will run, and event loop will start, and set timeout will be run in timer phase. So the execution order will be first of all this start and timer. We can check it from here, and just as we have predicted, we got our outputs. Now let us move to our another example. Now let us also tackle this unpredictable behavior of timer and set immediate. First of all, let's run it. Okay, so as you can see that immediate has been run before timer. Why does this happen? Let's try it again. Now then, the same code but different output. Why did this happen? Let's understand it. So why this behavior happens? So here's the code and the possible outcomes we have seen is the precedence of timer and precedence of immediate here. Both are correct behavior, just as we have seen. Now, let's understand the scenarios. Two scenarios we have faced here. First of all, timer phase run first because the event loop order here is something like timers, then poll, then check phase. Therefore, the output is our start, timer, and immediate. Now, the second scenario, which is check phase run first. Why this happen is sometimes the event loop reaches check phase before timers are ready. And this line is exactly the reason why the output is always unpredicted. Because the order here is the poll phase, check phase, and then timers. Therefore, the output becomes like this: start, immediate, timer. And that's it. We have tackled down our problem. Now we have got second example of ours, and you can see the interesting thing, the promise here we have. Do remember that. the promise is a part of microtask, and microtask always runs before timers. So if we go with our execution phases we have seen, we can see that we have console.log, which is part of a top level code. Another console.log is also, this one is also part of top level code. Then we have the promise, just as I told you, it is a part of microtask which has more precedence over timers. So what will be the execution order of it? First of all, this start, the second one is and, this one, and then we have our promise, which is this one, and then we have our timers. So if we check the output, just as we have predicted. Let's move on to our next. Now, as you can see, we have another very interesting example here. So we have log here, we have set timeout, set immediate, a promise, process dot next tick. This is what we will be learning here, the special thing about it, and then another log here. So the node will first of all execute the synchronous code, which is this log here, start one, and this one here. Then what will happen is, what you can see, it will run this code, process.nextTick. Why? Because next process.nextTick is prioritized by node. After that, the microtask queue will be run, which consists promise here. Then we have, then these two things will, which is a part of event loops, will run in their respective phases. First of all will be timers and then set immediate. So let's check our output. As we have predicted again, we have got two logs, next tick, which is prioritized by the node. Then we have our microtask, which consists promise here. Then we have, then the event loop starts and respective phases get executed, which is timer, then immediate. Now let's take a look at another example. Now you can see something interesting here. We have set them out, and inside that we have our promise. So what will be the execution order of this code example? Let's see. First of all, the async code will execute as always. The start one, then this end log. What will happen next? Microtask queue will happen, and this promise one will execute. After this, event loop will start because we have here set timeout. Inside this log will happen first, timer, and this promise will run after this. Do remember that the key concept, that after every callback, node runs micro tasks after every callback. Let's check our output. And just as we predicted, let's move on to another example. Okay, then we have got another code example with us. As you can see, we have promise inside set timeout and promise inside set immediate. What will be the output of this one? First of all, synchronous code will be executed first. So start and log will be executed first. After this, our micro task queue will have precedence and promise will be executed. After this, we have set timeout and set immediate inside our event loops. Just from our previous example, between where we compare the set timeout and set immediate's unpredictable behavior, we got to know this. We don't know what will be the output of it unless we run it, of course. Because between these two, any of them can any of them can be executed first. So it all depends on it. Let's check the output. If I, yeah, this one. As you can see, we have start and promise, and the timer one here has got the precedence because that particular phase has been running in event loop. For therefore, we have these outputs. Let's see again. Okay, we have got the same output again. Now, let's go with our last code example and the ultimate code example, you can also say. Here, as you can see, we have a log set timeout. Inside this, we have process.nextTick, another promise here, and outside of it, if we clip it down, then we have promise. Inside that, we have set timeout, and then we have promise.nextTick, then we have set immediate, and then we have another log here. After clipping it, we will be able to tackle it easily and will be able to predict the output. So first of all, the synchronous code will run first. Again, cut me off. After clipping, after now that we have clipped our codes, we can easily predict, at least we will have some advantage to see the clarity of the code. As you can see that this is the synchronous code and this one is the synchronous code here. This will run first. So A and I. First of all A, then I. After this, what will happen is, as you can see, process.nextTick, which gets spatial treatment by node, you can say. And this will run this G. So A, I, and G. After this, what will happen? Then we have our microtask queue, and microtask queue will run, and we have inside that a promise. Inside promise, we have a log E which will run. Then we have set timeout F, which is logging the F, and this will schedule F. Okay, this will schedule F inside event loop. Okay, after this, you can see that we have set timeout and set immediate, means our event loop starts, and then let's go with set timeout, and we have our a log b. This will run after that, and as you can see that process.next take and promise dot and a promise here which have c and d. What will happen with them? They will also schedule. So log c will schedule and this will also schedule. After scheduling it, as you can see that after every call back, after every callback execution, next queue always runs, and after that micro task queue always run. So what will happen is after scheduling it, we have got this will run C and then D. So as you can see, and after this again, as you can see this one, yes, we have set immediate here left, and this is H. So what will happen here is H will run. And do not forget that we also have this set timeout, which was scheduled. So what will happen is H will run first and then F. Why? Because of phases, the phases execution order. Okay. So what will happen here? Synchronous code A will run here, then I will run here because of their sync nature. Then promise dot, oh sorry, process dot next tick will run here, which will log G. Then we have our promise here, and this A will run, and I will scheduled. Then we have set timeout, which will run B. C and D will be scheduled, but after every callback, promise.next will get precedence, and this will run, and then this will run. Why? Because of every callback. After every callback, we run promise.next, and after that, micro task. All the micro tasks, whichever we have in our code, will run. As you can see, then we have set immediate H. This will run, and we have our left one, this F left, and then this will run. So A, I, G, E, and then B, C, D, and F, and oh apologies, F and H and F. Let's see the output. As we have predicted, we have A, I, G, E, B, C, D, H, and F. Hope you understood the internals of Node.js and the event loop, which exactly make Node.js magical.